pieces together that we just talked about in our first little video, and we're going to use them to sketch a parabola and draw an accurate graph. You guys ready? Let's go. All right. So we're going to graph y equals x squared. This is the parabola, the quadratic that we are going to sketch. All right. We've seen this before. We can graph this in our sleep, but now I'm going to use it to illustrate all the key components. So let's start by identifying a, b, and c, our coefficients. A is in front of the x squared. That's a 1. B is in front of the x. There is no x, so that's a 0. C is the constant. There is no constant, so that's a 0. Because A is a positive number, it's going to open up. Up because A is greater than 0. If my graph opens up, that means my vertex has to be my lowest point or my minimum. I'm going to have a minimum. My y-intercept is 0, c. To find my, which is going to be 0, 0. To find the x-coordinate of my vertex, which is also my axis of symmetry, I plug in the coefficient opposite of b, which is 0, over 2 times 1, which is 2, and I get 0. My axis of symmetry, which is the x-coordinate of my vertex, is equal to 0. It is a line. I'm going to draw it in red here. I'm going to try and make it kind of big so you can see it. This is my axis of symmetry. I make it a dashed line just so that it stands out from the other things that I draw and add on my graph. Now, in order to find the y-coordinate of my vertex, I plug in this value into my equation, the x-coordinate of my vertex into my equation, and I get y is equal to 0 squared. This one is really simple. They won't all be this simple. So I get 0, and my vertex is the ordered pair 0, 0. So let's put that on our graph right here, 0, 0. The domain is always negative infinity to positive infinity. My range, that depends on how the direction of my graph opening and the y-coordinate of my vertex. Because I have a minimum, my y-coordinate is going to be the smallest value, and it's going to go off to positive infinity. So I'm going to have 0, positive infinity. Now I'm going to make a table. I'm going to put the vertex in my center. I'm not going to recalculate. I get 0, 0. Now I'm going to pick a point to the left and to the right. To the left I have negative 1. I plug that in, and I get negative 1 squared. I get out a positive 1. And I'm going to plug in 1. That's my point to the right, and I get 1, 1. I'm going to plot these 2 points. I also know that because this is so simple and we're very familiar with this graph, if I plug in a 2, I get out a 4. If I plug in a negative 2, I get out a 4. Also, with the axis of symmetry, if I know this side of the graph, by symmetry, I know the left side of the graph and vice versa. And that is the shape of my graph. And notice that I get a U down here. I get a U down here. Okay. Let's try the reflection of the parent graph. This will give us exposure to a negative a. So here, my a is negative 1. There is no x term, so b is 0. There is no constant, so c is 0. This one is going to open down because a is negative, and that means if it opens down, that means my vertex is going to be a maximum. The y-intercept is 0, c, so it's 0, 0. I'm going to plug in 0 for b, negative 1 for a, and I get 0 over negative 2, and that gives me 0. Then I take this value and I plug it back into my equation, and I get negative 0 squared. 0 is not signed, so I get 0, so I get the vertex 0, 0. So let's take a second and let's put in our axis of symmetry. Again, I'm going to try and make it bigger so that it can be seen, particularly on the axis. Okay. This is the axis of symmetry. Okay, now I'm going to state my domain, negative infinity to positive infinity. My range, again, my range depends on the direction and the y-coordinate of the vertex. The direction and the y-coordinate of the vertex. Because my vertex is a maximum, that means that my smallest values are going to go to negative infinity, and my y-coordinate is going to be my largest value. Now I'm going to make a table of values. Let's plug in, this time, let's plug in let's plug in 2 and negative 2, right? So if I plug in negative 2, negative 2 squared is positive 4, and then I take the opposite of it. So I get negative 2, negative 4. Zero was my vertex, so there's no sense in recalculating everything there. And then 2, I'm plugging in positive 2, so I have the opposite of 2 squared. 2 squared is 4. The opposite of that is negative 4. And then we will see that this graph opens down. And here is my negative 1 and 1, and then we will just make a U like so. Our next section, we're going to talk about finding solutions, and that's where it either touches or crosses the x-axis. So keep that in mind. Let's try another one here real quick. Here's my equation that I want to graph, negative 2x squared minus 4x plus 4. So let's get our A, B, and C identified. A is negative 2, B is negative 4, and C is 4. Okay? So hit pause and determine if this graph opens up or down and whether you have a maximum or a minimum. All right, here we go. We're going to have, this is going to open down because A is less than 0. And if it opens down, that means my vertex is going to be a maximum. The y-intercept is 0c, so I get 0, positive 4. Go ahead and hit pause and see if you can get the axis of symmetry and the x-coordinate of the vertex. All right, here we go. Negative b, the opposite of negative 4, that's going to be positive 4, over 2 times negative 2. That gives me negative 1. Now I'm going to take this value, this is my axis of symmetry, the x-coordinate of my vertex, and it's negative 1. Let's go ahead and put it on the graph here. Here's negative x is equal to negative 1. That's going to be the center of my graph. Oops, didn't mean to do that. I meant to get my pen. All right, now I'm going to plug in negative 1, and I'm going to calculate the y-coordinate. So I have negative 2 times negative 1 squared minus 4 times negative 1. I'm not sure what that is, why it's making those noises, plus 4. All right, so negative 1 squared is 1. 1 times negative 2 is negative 2. Negative 2 plus 4, and that gives me 6. So my vertex is negative 1, 6. So I'm way up here. And I'm opening down. My domain is negative infinity to positive infinity. My range, I have a maximum. So that means the y-coordinate of my vertex has to be my highest value. So I'm negative infinity to 6. And now I'm going to make a table. All right? And I'm going to use symmetry on this one as well. Okay, so at negative 1, I have my vertex. I put that in the center. Just kind of keeps things balanced. All right, and then I'm going to pick negative 2. Let's see what I get. I have negative 2 times negative 2 squared minus 4 times negative 2 plus 4. Okay, so we get here negative 2 squared is positive 4 times negative 2 is negative 8. Negative 8 plus 8 is equal to 0, and 0 plus 4 is 4. So I get negative 2, 4. And then if I plug in a negative 3, I'm going to get y equals negative 2. I'm going to go 9, and then plus 12 plus 4. So this is 16. 12 plus 4 is 16. Negative 2 times 9, that's negative 18. So I get negative 3, negative 2. If I plug in a 0, this is my y-intercept. I'm going to just label it y-intercept. I could have used that first. That would have been smarter. And then use symmetry. And then I'm going to use symmetry here. So if I plug in a 1, I'm going to get negative 2 for balance. Okay? All right, and then I'm going to go negative 3, negative 2, negative 2, 4, and then I have 0, 4, and then I have 1, negative 2. And I'm going to make my U. Okay, like that. All right, this is the last one we're going to do. Don't worry about the solutions. We're going to do that tomorrow. All right, so A is a half. B is 3. C is negative 6. All right, I want you to hit pause and answer 2, 3, and 4. All right, here we go. This is going to open up because A is greater than 0. That means I'm going to have a minimum. My y-intercept is 0, negative 6. My axis of symmetry is negative 3 over 2 times a half. 2 times a half is 1, so that gives me negative 3. Now I'm going to plug in. All right, so this is the line x equals negative 3. It's also the x-coordinate of my vertex. So let's go ahead and put this on the coordinate plane. This is our axis of symmetry. Go ahead and include this on all your graphs because it'll help you. Right, and now let's plug this in and figure out what we get. So I have 1/2 times negative 3 squared is 9. Minus 9 minus 3 times 3 minus 6. So this is negative 15. So I have 9/2 minus 15. So that's going to give me negative 21/2. Okay? Or negative 10.5. So I get negative 3, negative 21/2, or negative 10.5. And I'm going to go ahead and put that in my table right now. Negative 3, this is, just label this vertex. You get negative 3 times, not times, negative 21 over 2. There we go. And now I'm going to put in my y-intercept, 0. I'm going to label that y-intercept. So I get 0, negative 6. All right, now, so if I go, so here's, you know what, I need to do this by 2s. Let me erase this right here. Let's make each of our lines a 2, each of our grid be 2. So this is 2, and this is 2. And so if I go -3, this is -2. Here we go like this, just so that I have enough space on here, okay? Again, don't worry about the solutions, okay? All right, that's my axis of symmetry. X equals -3. Okay, all right, and then 0, here's my 0. Let me go back to purple. And I'm going to get 0, -6, -2, -4, -6. So here is 0, -6. Okay. And I have my vertex at -10.5. So here's -8, -10, -12. So I'm like right here. This is going to be my vertex. All right, now let's use symmetry. If I went three units to the right and I'm at -6, what happens if I go 3 units to the left? Well, I'm going to be at -6 because that's what the axis of symmetry does for us. That's the power. So there's -6. And then let's just try plugging in a 1. Let's see if we can get it to cross the x-axis. So if I plug in a 1, this is going to get in my controls here, sorry. Let's plug in -8, and then we'll use symmetry. So I have y equals 1/2. 8 squared is 64, and this is 3 times -8, that's -24, -6. So these two are -30. This piece right here is +32, so I get -8, +2, which means I'm going to get 1, +2 as well. So I'm going to be here, and I'm going to be here. And then let's just draw this. All right. We're going to have a worksheet tomorrow. Thanks for listening. Rewatch any of the components you're not sure of, and I will see you in the morning. Thanks.